The first thing we want to do for this example is to determine the minimum number of unknowns that we need for nodal analysis. This process serves two purposes. Later on, after we've identified our node voltages, we can compare that to this assessment to make sure everything makes sense. And more importantly, if we have more than one analysis approach available to us, we want to pick the one that results in the least amount of work. Usually, the approach that results in the minimum number of unknowns is less work. There are a couple of ways to do this. They're really both the same thing, but they feel different. For my first approach, what I'll do is create what's called a supernode around the voltage sources. So this voltage source can go inside a supernode, which makes this entire area one supernode. This voltage source can also be put inside a supernode, which means that this whole area is a single supernode. After we've created our supernodes, we count all the nodes in the circuit and subtract 1. That gives us our total number of unknowns. There aren't any nodes in this circuit other than the two supernodes. So that gives us 2 nodes. If I subtract 1, then that results in 1 unknown. The second approach is more or less the same thing, but it gives a more explicit approach towards creating supernodes. In this approach, we do what's called killing the sources. That means that we replace voltage sources with short circuits and current sources with open circuits. So the voltage source V1 will become a short circuit. That resistor remains as is. The voltage source V2 also becomes a short circuit. That resistor remains that way. The current source becomes an open circuit. Now after we've done that, we again just count the nodes and subtract 1 again. Perfect conductors can go inside nodes, so this is again just one node, and this is just one node. The voltage difference across this open circuit is unknown, so this node and this node can be at different voltages. So again, we have 2 nodes. We subtract 1 from that, and this results in 1 unknown. Doesn't matter which approach you use, they should both give you the same answer. The rest of this example consists of defining different variables for this circuit, all of which will be valid, and the important thing is to notice that none of them are necessarily better than any other. To define valid node definitions or circuit unknowns, the first thing you do is choose a reference node. The reference node is completely arbitrary. For this first example, I'm going to choose the reference node down here. So that's my reference node, and that becomes my assumed 0-volt level. The next thing I'm going to do is define dependent nodes. Dependent nodes are separated by voltage sources. For example, at V1, this node here and this node here are dependent on one another. You know the voltage difference between those 2 nodes. When I'm defining dependent nodes, the node on one side of a voltage source will be dependent. The node on the other side will be generally independent. It doesn't matter which you choose as which. I'm going to choose this side of the voltage source V1 as being an independent node. I'll call that voltage V sub A. If this voltage is V sub A, and this voltage source says that this voltage is V1 volts higher than this one, then this node is dependent, and its voltage is going to be V sub A plus V1. The nodes on either side of this voltage source will also be dependent on one another. I've already decided this voltage is 0 volts. This voltage is V2 volts above this voltage, so this voltage is just V2. Finally, if there are any remaining nodes in the circuit, those will be independent. There aren't any other nodes in this circuit. So in this circuit, there's only one unknown voltage, which is consistent with our previous slide. Now let's define a second set of node definitions for the same circuit. Again, choose a reference node. That choice is arbitrary. This time around, I'm going to call this node V sub R, and that's my assumed 0-volt level. Next, I define dependent nodes. Again, for each source, I'll choose one side of the source as being independent and the other side will be dependent. So for this source, these two nodes are dependent on one another. I've already chosen this side to be 0 volts, so this side is V1 volts higher than this side. So this becomes 0 volts plus V1, which is just V1 volts. Keep in mind that V1 is a known value, so neither of these voltages are unknown at this point. Down here, these two nodes are dependent, the nodes on either side of V2. I'll choose one of those as being the independent node. Let's call this one VA. If this is VA, then this node down here is V2 volts below VA. The negative terminal is down here, the positive terminal is here. That means that VA is V2 volts above this voltage, so this voltage down here is V sub A minus V2 volts. Finally, any remaining nodes are independent, but this circuit still has no additional nodes. If I check my unknowns, VA is the only unknown voltage, so this circuit still has one unknown node voltage, and that variable name is V sub A. Just to keep hammering away at the idea that these node definitions are somewhat arbitrary, let's do the example one more time. My first step is still going to be to define a reference node. That choice is entirely arbitrary. This time around, I think I'll call this my reference node and make that 0 volts. Next, I choose my dependent nodes. So the nodes on either side of V1 are dependent. So this node and this node are dependent. I've already assigned this to be 0 volts, so this node over here is V1 volts below 0. The negative terminal is on this side, the positive terminal is on this side, so this voltage is 0 volts minus V1. The nodes on either side of the voltage source V2 are also dependent. Neither one of them has been assigned yet, so let's arbitrarily choose this as my independent node. I'll call that VA. Then this becomes a dependent node. This node is V2 volts above VA, since this is the positive terminal, which just makes this VA plus V2. There are still no other nodes. If there were other nodes, then those would all become additional independent nodes. So the circuit still only has one independent node voltage. That voltage is V sub A, and it's the voltage at this node down here.